Hello everyone, I'm Professor Harrison, and welcome back to our module on regression analysis. Today we're going to be covering simple linear regression. We're going to look at the model itself and how to picture a single line drawn through a cloud of data. We're following Margot. She's a graduate student trying to reassemble a story that her family buried. Today she's pulling up her grandfather's old fund returns to ask a pretty basic question. How much of the fund's month-to-month movement was just the market moving, and how much was it something else? She pulls up another page from her grandfather's fund records. Simple linear regression is a way of describing how one variable moves with another using a single straight line. So here is Margot's setup. She has her grandfather's monthly fund returns going back for years, and for each of those, she also has the return on the overall market. She wants to know whether there's a relationship between the two. When the market had a good month, did the fund tend to have a good month too? And if so, by how much? The place to start is just to plot it. Every month ends up becoming a single dot, and the market's return to that month is on the horizontal axis, and the fund's return on the same month goes on the vertical axis. We can do that for every single month, and we end up with a whole cloud of dots. That's a scatter plot. Now the dots don't fall on a perfect line, but you can kind of see a trend running through them. Simple linear regression is the tool that draws the single best straight line through that cloud. So we write down a model for it. We say that the fund's return in a given month equals an intercept plus a slope times the market's return for that month plus an error term. In symbols, that's beta 0 plus beta 1 times the market return plus an error term that we're going to call epsilon. So really there are two pieces here, and it's kind of worth pulling them apart. The first piece is beta 0 plus beta 1 times the market return. That's going to be the straight line part. It's the systematic, predictable piece, and if you feed it a market return, it's going to give you back exactly one number, the point sitting on the line. The second piece is the error term, and that's everything else. It's the gap between where the line says the fund should have landed and where the fund actually landed that month. One common question is why we even need an error term at all. Why not just draw the line and call the line the relationship? Well, because no straight line is ever going to pass exactly through every single dot. Unfortunately, the dots are scattered, and that scatter isn't a mistake. It's real and it carries important information. The error term is where we put everything that affects the fund's return that the market return simply doesn't account for. There are other things going on in the portfolio, measurement noise, plain randomness, and anything we left out of the model. If the market was flat on one month but the fund jumped anyway, that jump didn't come from the market, so it ends up living entirely in the error term. Now there's one more distinction that matters here. There's a true relationship out in the world, a real intercept and a real slope that actually govern how this fund responds to the market. That's called the population regression line. The catch is that we never get to see it directly. What we do get to see instead is the sample regression line, which is the line that we estimate from the data that we actually have in front of us. So when we write our formula, the estimated intercept and slope get little hats written on top of them, beta 0 hat and beta 1 hat, just to remind us that they are estimates and not the actual truth. The way that I keep these two things straight in my own mind is pretty simple. The population line is the truth that we're never going to see directly, and the sample line is our best guess at that truth, which is what we build from the data that we happen to have. So picture that scatter plot one more time. The line is our best straight line summary of the whole cloud, and the vertical distance from each dot to that line is that month's error. How far off that line that particular month landed? A month sitting right on the line has almost no error, and a month sitting far above or below the line has a very big one. Margot sits back and looks at the scatter plot she has built. Most of the dots hug the line. The fund mostly just move with the market, the way that you would expect. But a handful of months sit way off the line. Those are big errors. And the errors come from the part of the fund's return that the market can't explain. And those off-the-line months are not scattered randomly across the years. It seems that they bunch together. They cluster into one stretch of time. So she pulls up Bess's old report on the case. Bess had flagged a specific window when the rational quant was trading most heavily against the fund. It's the same window. The months that the market can't explain are the same months that the rational quant was most active. She marks it down. She doesn't yet know what it means, but for the first time, two separate piles of evidence are starting to point at exactly the same stretch on the calendar. So that's simple linear regression. The whole idea is that we split our outcome variable into two pieces. There's the part that a straight line can explain, which is the systematic relationship between the two variables. Then there's the error term, which holds on to everything that the line leaves out. That error isn't junk to be thrown away. It's where all the influences we didn't put into the model end up sitting. We're really after the true population line, but unfortunately we can only estimate that line from the sample. As we'll learn in the next video, we can use this line to interpret the relationship between our variables.